Okay. Are you done? Okay. First, we're going to talk about how to find a common denominator because we need to be able to find a common denominator in order to solve the equations we're going to solve. We've already done this, so this is a quick review. If you need to find the common denominator for these two numbers, what method have we been using?
Cake.
Cake method, and look for what? Common factors. So what what common factors do they have? 2n, which leaves us with
3n squared.
3n squared. So if we multiply these, we get, okay, 6n cubed. We're going to look at that in a second. Now let's look at this one. We want to use these two. So what do they have in common? 5n squared. So 5n squared, leaving us with and so if we multiply all three of those, we get 30 into the fifth. I want to point out a shortcut for these because they're just monomials and we don't have to factor them into binomials or anything like that. What is a common denominator? If your denominators were only 10 and 15, what would your common denominator be? No, that's your common factor. What would the common denominator be? What's the least common multiple? 30. And then which one of these ends has a higher exponent? The end of the fifth? Okay. 6n and 6 and 2. If you were writing fractions with 6 and 2, what would your common denominator be? 6. You could use 12, but 6 works. That's our 6. Which one of these has the higher exponent? N cubed. N cubed. So if you had the fractions 3 over 7n to the fourth and 2 over 21n, what would your common denominator be? 21n to the fourth. Does that mean you can't use the cake method? No, you can still use the cake method, but with monomials, this method's going to make things speed up a little bit. Okay, so here's what we're really doing. We have an equation to solve here. Would you agree it's relatively ugly? Yes. It's got fractions in it. So the very first thing we want to do is try to get rid of all the fractions. And we can do that by multiplying on both sides, multiplying every fraction by whatever the common denominator is. So what's the common denominator for m squared, 3m squared, and 3m squared?
3m squared.
3m squared. So we're going to multiply all of these fractions by 3m squared. So when I multiply the first fraction times 3m squared, what cancels?
M squared.
Just the m squareds, leaving us with 3. And what operation are we doing? So 3 times 3 is?
9.
Then we need to multiply both of these by 3m squared. So when we multiply the first one by 3m squared, what cancels? The 3m squared down here cancels with the 3m squared up here. When it cancels, it leaves us with a 1. So what's m minus 4 times 1? Then we need to multiply that 3m squared times this one. And what cancels? The 3m squareds cancel again. Your numerators aren't going to cancel with anything because your denominator down here is always going to be a 1. So you're really just looking at the numerator and the denominator. Those completely cancel again, and 1 times 2 is 2, so plus 2. This is just a linear equation because m is to the first power. So we're going to go ahead and combine like terms there, and we get m minus 2. Add 2 to both sides. M is 11. Is 11 okay for our denominator? Yeah. What's the only thing our denominator couldn't be for this problem? I'm sorry, m. M couldn't be 0. because that would make all the denominators 0. Okay, so we found the common denominator, and then we multiplied all three fractions times that denominator. Let's do that one more time. 2n, 4n squared, and 4n. So 2, 4, and 4. What would the common denominator be?
4n squared.
4. N and n squared, n squared. So we're going to multiply both sides by 4n squared. So we multiply it times the first fraction. With the 4n squared and the 2n, what cancels?
2n.
And what does that make this? 2n. So 2n times 1 is?
2n.
Now this becomes 4n squared again, right? Let's get rid of that. So now we're multiplying it times the second one. What cancels?
4n squared.
4n squared cancels completely, leaving me with 1 times 1, which is 1. Be very careful. When they cancel to be 1, not 0. Remember, because you're just dividing. What does this cancel to? The 4's cancel? So it leaves me with an n up here. N times 1 is n. It's a linear equation just like the last one. We just get our n's to one side. Minus 2n. 1 is equal to negative n. So n is equal to negative 1. So find the common denominator, multiply by the common denominator. I do want to point out one thing. If you have a fraction 1 over 4n minus x plus 1 over 2, what do you have to do with this minus?
I don't.
And what do you apply the negative to? Just the x or the x and the 1?
Both.
Both. So add up. Be sure that both of those get the negative. That's a real common error, so be careful with those. All right, that's it.